Section 8.3. Our objective today is I can state and apply the converse of the Pythagorean theorem and theorems about obtuse and acute triangles. So first of all, remember the Pythagorean theorem said that if you have a right triangle, then c squared equals a squared plus b squared. And so the converse says if the square of one side of a triangle is equal to the sum of the squares, of the other two sides, then the triangle is a right triangle. Okay? So it says if c squared is equal to a squared plus b squared, then the triangle is a right triangle. Okay? So if we're given three lengths, we can determine if those three values form a right triangle. Okay, so if we're given the lengths 16, 30, and 34, okay, well, the longest side is always your C, okay, so then 34 squared, we want to know, is that equal to 16 squared plus 30 squared? Okay, so 1,156 is 34 squared. 16 squared is 256. And 30 squared is 900. And if we add those together, we get 1,156. Those are equal. So these are the sides of a right triangle. So we can say it is a right triangle. Okay. If I have, for instance, the sides 3, 4, and 6. Okay. So is 6 squared equal to 3 squared plus 4 squared? Well, 6 squared is 36. 9 plus 16 is 25. So this is greater. So this is not a right triangle. Okay. Then there are what we call Pythagorean triples. In other words, these are values that always give you a right triangle. So the most common triple is the 3, 4, 5 triangle. Okay, and multiples of that. So if I multiply all those by 2, it'd be a 6, 8, 10. Okay, etc. Right? So a 3, 4, 5 is always a right triangle. A 5, 12, and 13 is always a right triangle. And again, multiples of that. So 10, 24, 26. If we multiply by 2, we can multiply by 3, etc. We also have 8, 15, 17 is a Pythagorean triple. And the last common one is a 7, 24, 25. Okay, so those are all Pythagorean triples. Okay. Now it turns out that we can determine what kind of triangle we have by determining is the longest side, the square of the longest side, greater than the sum of the square of the other two, or is the square of the longest side less than the sum of the squares of the other two. And the theorems go like this. The first theorem says, if the square of the longest side of a triangle is greater than the sum of the squares of the other two sides, then the triangle is an obtuse triangle. Okay, so in other words, if c squared is greater than a squared plus b squared, then triangle ABC is obtuse. Okay, so if c squared is greater than a squared plus b squared, then it has to be an obtuse triangle. And the next theorem says, if the square of the longest side of a triangle is less than the sum of the squares of the other two sides, then the triangle is an acute triangle. So in other words, if c squared is less than a squared plus b squared, then triangle ABC is acute. Okay, so let's look at some examples. So determine whether the triangle is acute, obtuse, or right. Okay, so A, if I give you 8, 12, and 13, okay, so you always check to see, do these three form a triangle. So remember that the sum of any two sides has to be greater than the third side. So 8 plus 12 is greater than 13, 12 plus 13 is greater than 8, and 8 plus 13 is greater than 12. So it checks, it does form a triangle. Now we need to figure out what kind of triangle. So then we look for the longest side, which is 13, and we say, is 13 squared less than, greater than, or equal to 8 squared plus 12 squared? Well, 13 squared is 169, 8 squared is 64, 12 squared is 144. And so when you add those together, you get 208, and this is 169, so this is less than. So c squared is less than, so that means it must be an acute triangle. Okay. B. Let's say I have 4, 4, and 7. So again, first check to make sure it makes a triangle. So 4 plus 4 is greater than 7. 4 plus 7 is greater than 4. And again, 4 plus 7 is greater than 4. Okay, so it checks. It does make a triangle, and so then we take the longest side and we say, is that less than, greater than, or equal to 4 squared plus 4 squared? So 7 squared is 49, 4 squared is 16, and 16, so I get 49 and 32. That's greater. So the longest side is greater, so this is an obtuse triangle. Okay. Let's try one more. So if I have square root 5, square root 5, and square root 10, okay, so square root 5 plus square root 5 is greater than square root 10, and square root 5 plus square root 10 is greater than square root 5. And then the other one would just be this one again. So this is true. So is the square root of 10 squared greater than, less than, or equal to the square root of 5 squared plus the square root of 5 squared? So square root of 10 squared is 10. This is 5 plus 5. So these are equal, so it is a right triangle.